Good evening once again and welcome to Tinker Tailor Solder Fry, the Let's Try program here on the mighty Loading Ready Run Video Entertainment Network. My name is Ian Horner and I will be your navigator through today's proceedings. But before we get into anything, we want to remind you, if you're new here, that everything we do here is brought to you by your kind support over at patreon.com/loadingreadyrun, which is one of the many ways that you can help us out over youtube.com/loadingreadyrun, twitch.tv/loadingreadyrun, but patreon.com is the one we want to remind people of because it happens every month, and that really helps us out because we continue also to exist month to month, and you help us continue to do that. So thank you so much. Today we're going to have a potpourri, I guess, of projects. First thing we're going to do is, hey, remember this? We finished it. We played video games with it. It's done, right? No, not done yet. We still have one more part that I would like to continue on with this device, and that is to mount this into something nice. I want to consoleize this. I want to make this something that's easy enough that you can just plug in the power, plug in your controllers, turn it on, and of course plug in the video, and get to gaming. And in order to do that, I'm going to need some form of a case. But you know, we could build up a large arcade cabinet, but we don't really have that much space in the moon base for something like that, and it's difficult to move around. It's annoying to be stuck in front of a cabinet, or to have to wheel a cabinet, or to find space for a cabinet to go. But one thing the moon base is not lacking is wall space. So my plan is to take this device and its power supply and the Raspberry Pi and all the ancillary other bits, including the GD-ROM, which I helpfully forgot at home today, and we're going to put it under glass. We're going to lay everything out on a nice little sheet of wood, probably that stuff with the pegboard stuff. We're going to cover that over in some black felt, you know, just to give it a nice backdrop. We're going to mount the Naomi, the Raspberry Pi, maybe the power supply, but definitely the GD-ROM, and we're going to knoll the wires coming out of those so they make nice little arcs and then disappear into the felt to a rat's nest behind. And then, of course, we'll build up a wooden surround on that and cap it off with a big old piece of glass and a nice ornate frame. The only questions I have to myself is, do I want to hide the power supply because it's big and nasty looking, or do I want to make some sort of a case for it, 3D print something that will match the style of the Naomi with its fins and lines, and maybe I can, hopefully, if I'm lucky, match the color and we can spray paint it up. I want to do that with the Raspberry Pi as well. But before we can do any of that, we need to know how big of a frame we're going to need, and to do that, we're going to need to take some measurements. And then I'll go hunting for frames, and we can start the work in putting it all together. But that's for a future episode. What a lot of arcade machines are, Naomi screwed onto a piece of plywood inside a cabinet with a TV on top. Yep, that's pretty much it. Naomi plus pedestal plus TV equals instant arcade roulette. Also good. I like the idea of having it on the wall, though, as a display piece for when we're not playing with it. And because of the way we've set things up with the Raspberry Pi as the server for the JVS for the input systems, we can actually just use Bluetooth controllers. You know, connect our Xbox One controllers up to this thing wirelessly and play the games that way. But I mean, the real fun's with the arcade sticks, which we can also do via the USB. But for now, let's. There we go. That's the focus point. Just have a nice look at the beautiful input on there.
So this will be kind of like a shadow box for the Naomi, I guess.
That's exactly what we're looking to do. And then, of course, on the edges of those shadow box, behind the edge of the frame, we'll have the ports for your HDMI, your USB, and your powers, and of course a big old honking power switch, so that those all are hidden when it's just sitting there on its own, but ready to play at a moment's notice. Take it off the wall, plug it in, and go. So yeah, we should probably just start by taking measurements, and that's going to be a quick bit here. So as I said, though, one other thing, I did forget the GD-ROM at home. We'll need to take measurements for that to add things in. We can, roughly estimate for now, because of course we're not going to know exactly how much space we're working with until we get a frame. We'll have to match those up together when the time comes for it. But if anyone out there does have on hand a GD-ROM or knows where they can find, believe me, I did some very frantic searching beforehand. If you know what the dimensions of a GD-ROM for Naomi is, pop them in the chat, and I'll end up using those.
Now, if I recall, when the Naomi turns on, it is not, shall we say, whisper quiet.
No.
There's a lot of fans and stuff going on inside.
Yeah.
So obviously, if we're enclosing it in a shadow box, we're gonna have to have some kind of ventilation and stuff in there, right?
Yeah, we're gonna have to think of either probably perforate the edges of the shadow box behind the frame there, or maybe even add some fans there as well. But I think I've got some ideas in my head on how to build that frame in such a way to allow for some ventilation. And of course, as long as you've got the frame propped up against a wall, you can maintain you can maybe maintain an open airway from the bottom of that frame up to the top, parallel to the glass.
Are there any guidelines as to what orientation the Naomi should be in?
Not in the service manuals that I frantically looked through looking for dimensions. Hey, by the way, as well, anyone who's publishing information on the internet, when you're publishing specifications, dimensions are a form of specification that you should probably add as well, please. That's my plea for the future. I think we should also want to clean this up a bit too, if we can. Just make it a little bit. It's still got dust and some weathering from its previous life inside an arcade cabinet. But yeah, let's get started on making some measurements, shall we?
Do you happen to know the provenance of this Naomi?
I do not, because we received it thankfully from Dandy Geek for use here at Moonbase. They may be able to fill us in on some of the earlier life of it, but as far as I know, I only know its history from the time it hit my hands. So. They were a pretty prolific arcade machine, from my understanding, though. I mean, we had, what was the game that I was threatening Beej with? If you ever saw even Mario Kart in the arcades back in the day, that was Nintendo games running on Sega hardware, which is a wonderful blasphemy.
Ooh. And that was like back in the day before they were buddy-buddy.
Yeah. I think we can also point back to a previous episode of Rhythm Cafe, where we played Rhythm Heaven. Again, a notorious Nintendo game on this notoriously Sega console. Yeah. Beautiful little piece of kit and extremely powerful. So, let's, I guess, start with just taking the base dimensions of the guy. I'm going to get out a ruler for that, which is, just barely not long enough. But we can make inferences based on that. So I'm just going to line this up here on the grid, and then we can make our first measurements from there. So what we're looking at feet-wise to feet-wise, because we're going to want to keep the feet in there, I think. And starting with, we've got 38. Wow, this is the markings on this this mat aren't the greatest.
Oh, are they not that accurate?
They're not as accurate as say the ruler is, and they're not lining up.
Oh, no.
For example, we can bring it up here. So if I go to the very far edge of that printed line up here as my 0 mark, 38 millimeters on the ruler is 1 millimeter longer than the grid point line. Which is
So it's 1 millimeter over the over the length of, so it's probably about at least 2 millimeters out over the length of the entire mat.
yeah. If I were to if I'm trying to read this like a vernier caliper, trying to find out where the matching number would be, and yeah, it seems like 2 centimeters is the closest it gets to being accurate, and then just that point, that fraction of the millimeter. Just amplifies and multiplies up through it. But like I said, we can just use this as the cutting mat as a form of making sure that we've got our lines straight.
That's true. It is a mat made out of rubber, and rubber that has been, cut and rehealed itself multiple times.
Okay, so we're looking at, if we consider that line there, do I have something that I can mark that with?
Dandy Geek says, I think at least the GD-ROM came from Spain.
Oh my.
It is, so it's scraped from, it's parts scraped from eBay, so it's possible that the different parts have come from different places.
Right. But yeah, Spain for the GD-ROM is that's a good distance. Here we go. We can use this and wait, is that a good tool back there for this? Yes, this will be perfect. We'll use the needle point on one of these sets of pliers as a position marker. Now, I don't think I need to get extremely accurate with these readings, but hey, what if we are, if not pedantic, a lot of the time? All right.
I suppose you want to err on the side of slightly larger if necessary as well.
Exactly. So we're going to say that this point here is 36 centimeters. And oh wait, no, that was me with the ruler out of the right area. Okay, so let's put that at 37. And we are looking at, whoa, dang it. Boy, if you're going to do this, do it right. Okay. We are now pointing at the 37. And let's extend that out. So it's 37 plus 1 centimeter. And we are looking at, on the cross reading, there you are, T-square. 37 plus 2 more millimeters. So that's 38.2. Good. Good start. All right, box. Let's make you 38.2 centimeters long.
I feel like if we, if you laid out all of the components on this mat, and then we just took a screenshot from the overhead camera.
Oh, I'd worry a bit about the. I'd worry a bit about
There's some
the distortion.
lens distortion and stuff.
But still, that's fun. Gosh. They've changed so much. No. Where is document setup nowadays? There it is. Let's say we're going to start with Yes, I would like to edit the artboard. There you are. Transform. We're going to want that to be, I don't know, let's go 36 inches wide by 24. That's roughly the size of a 36 inch by 24 inch. There we go.
I mean, it's a good idea, as someone pointed out, especially for the mounting process and the cable routing and stuff. Getting a sheet of sort of poster board or something and sort of tracing all the elements out on it.
Mm-hmm. That's not a bad idea.
And that would also, and like where all the screw holes will be and stuff. That would help for sizing.
Yeah, I guess we're kind of doing that with by putting it in Illustrator, but yeah, just actually laying it out physically is fun too. But Naomi 2, let's see, we are at 38.2 centimeters, and we're going to find out the cross dimension here in just a second. All right, this one we're going to have to measure based on where the actual edge of the console is.
I didn't know Illustrator was tied into Adobe's generative AI stuff.
Sure are. Sure not happy about having that shoved down my throat, but
It is tempting to just, generate, Naomi console layout.
all right. The edge right now we're looking at 26 point. All the reflections are giving me a real hard time here right now. 1, 2, 3, 4, 3. 26.3 centimeters. Again, probably way too close. And then we're going to want to get the full height as well. So that's where we're going to use a fun new toy. Calipers, which are so nice as to remind me that this material produces no noxious hydrogen chloride fumes when incinerated.
Is that something that you're liable to do?
That's something I'd never thought would be an issue, but here we are. All right, and we're going to plunge this. Boop. Hey.
It's like one of those one of those big marketing, emblazoned package that's like now non-radioactive.
Well, we were lucky there, and then I realized we're not lucky because I have not added all the height yet.
Ah, yes. It's got a
top bit here. So maybe we can undo that. Yeah, let's do it from that side. Okay, and we'll just use you to hold that up for the moment. There we go. And continue our plunge path. That seems like it's going to be more accurate. All right, we are looking at, oh, thank God, everything lines up just perfectly. 120 millimeters. Ooh, no, wait, 121 millimeters. Let's read that there again, yep. So 12.1 centimeters high.
and it looks like the the power supply is shallower, so presumably that's the. If we're talking about like how deep this box has to be,
Yeah.
that's sort of the limit.
That was going to be one of our big questions, was how much is this going to, how much are we going to have to build depth into this, this shadow box? And just thinking right now, if we're 12.1 centimeters high, we'll use our good friend solver in inches. That's 4.7 inches, or 4.76, so roughly 4.5, 5 if we want even a 1/4 inch clearance, because we're also going to have some felt there. And that's, again, not going to be much of a clearance, but decisions we will have to make. But that's definitely good to know. Just playing 2 inches off the Naomi. That's an option. I mean, we could shave. Actually, I didn't realize until just now that we can actually take these feet off the bottom. But I do like the sticky outy feet. I think they're aesthetically pleasing to me.
Are the
So.
is the area like the sort of underneath, like there's sort of the not only the feet that come off the side, but also the sort of pedestal area in the four corners.
Mm-hmm.
Is that like if you say removed the plastic case completely?
It sounds like there's a lot of space in here, to be honest. Just
Yeah. So
tapping
like
around.
theoretically, not saying this is a good idea,
Yeah.
but theoretically, one could make the whole thing quite a bit shallower.
We
than
could
it
make a
is.
naked Naomi, but honestly, it's such an interesting looking console. You don't see this shade of blue that often in plastic.
It's true. It's true.
Yeah. And the insides, I mean, as interesting as they are, they're pretty much similar to just about any other unknown arcade or circuit board, unless you know what you're looking for specifically. You do get the nice big Sega logo, but there's a few heat sinks in there. Yeah, all of the airflow, though, seems to be on top, and the bottom is completely...
Oh, that's good.
Yeah, just completely sealed up. So, in fact, the sides too, you have the air intake from the giant fan, which we could maybe replace with a Noctua.
Interesting that because the way it's sort of lifted up like that, it seems like it's giving itself ground clearance for
Right. You'd think it'd get a bit more airflow under there.
for like an intake. Yeah, but interesting.
But yeah, we could absolutely, if we want to add more venting to it, we could put computer fans along the bottom edge or the top edge of the frame and run those through a temperature probe too to provide variable cooling if need be. But I mean, these are as much as you should take care of your things and give them proper ventilation. Remember, most of these were thrown inside of a wooden cabinet with their own airflow issues. So these are built to be industrial machines, not necessarily consumer grade stuff.
Yeah, someone in the chat says, yeah, we need to replace the case with one of those like the sweet 90s like transparent plastic, like they a Game Boy or something. They had like the special edition transparent plastic versions.
The Bondi stuff, all good stuff. Can you orient the Naomi so the air intake is at the bottom and the exhaust is on top? Absolutely, we could, Mercano. That would be something we could put in the. Well, actually, no, we can't.
It's a 90. It's like a 90-degree.
Yeah, the air intake is on the side, and all of the air output holes, which are here,
Are on the
and
top.
here, are on the top. So they're going to have at least an inch of clearance on their own, just based on this bad boy. Before
Oh,
you
that's
get to
good. Yeah, that's a good point. Yeah.
But there's, if we were to say, like, put the air intake at the bottom, the top of the case is where all the I/O is. And I think just for aesthetics, we're going to want to mount it vertically like this so that you can read the label.
Right.
I'll need to clean off some of that masking tape too off parts there. All right, but the power supply is going to be the toughest one because it's the thing that's the most custom in this build. It's you can apparently use PC ATX power supplies, but you definitely need to get the correct connectors on them. And on top of that, you do need to do a little fiddling with the voltage to make sure the Naomi is apparently fairly picky about what it gets.
Yeah, I would guess modern power supplies are probably don't have the same ends and stuff on them.
Well, I mean, they definitely don't have the same ends. These are very proprietary Sega connectors.
Right.
Yeah, and they're getting harder and harder to find because I think almost all of the new old stock has been already snapped up. And as plastic ages, it tends to get more brittle, so all the original stuff is starting to disappear as well from multiple reconnections, et cetera, et cetera.
But yeah, it's amazing the super sort of micro ATX style power supplies they have now. You can get they go up to 700, 800, 900 watt power supplies that are extremely compact.
Teeny little boxes. I mean, the Pico power supplies were the ones that I lusted after back in the day when it was just something that about the size of of the input socket on the motherboard itself as an entire power supply.
Wow.
That would just be connected via a barrel connector to a big old wall board outside of it.
Of course, that's always the secret. Is they're like, oh, look at how small it is.
Yep.
And then giant wall board. It's like, well, the other one is big because the wall board is inside the case.
Yes. And it can be pretty difficult too. I mean, if you're trying to get something that's going to into a wall wart that's going to put out 3 different voltages, then yeah, that's of course it's going to be big. But we are looking at for this. Oh, this is thankfully nice and metric. We're looking at 18 centimeters directly on the back end. Power. Supply is spelled with a P and with an S. 18 centimeters, bracket X bracket to make a proper multiplication sign. And this one, again, we want to make sure that we're lining it up properly with the line. Other direction is tap, tap, tap. 15 centimeters on the dot.
Nice. I always respect. It's one thing I've always respected about the Mac Minis, that they don't have a wall wart.
That's quite impressive.
Like they're using about a third of their internal volume for the what would normally be the wall wart, the the DC converter, and so it's just a nice clean power cable coming out the back.
3-pronger. All right, and again, nice and clean, but not a round number this time. We're looking at 8.7 centimeters.
I mean, I guess the depth doesn't really matter other than the deepest thing. Although, unless you want to make a case around it.
Well, yeah, we were considering that too, but we'll see how that goes. It's either make it a case and display it inside, or kind of try to hide it behind the frame itself. And honestly, given the size that we're going to need to work with, hiding it inside the frame might not be the bad idea. But that's something we will come to when it comes to it.
I wonder, I almost was thinking about, like, you could almost use, there's the kinds of tricks that they use for magic tricks, like to make, there's things that you can do with a shadow box to sort of make it like have the base of the shadow box be sort of deeper. So it looks like everything in the shadow box is
on the incline?
No, isn't as deep, because it looks like it's just sort of offset from the wall a little bit. It's like how it's how they can hide a person to when they do like the chop in half thing. They have like a you know, the bottom of the container is not actually where you think it
Right.
is. You can kind of do some tricky stuff like that.
Mhm.
Optical illusions.
So we're gonna have to play around with these as well when we with the wires. Probably want to pull them out of the connectors, and then we'll snake them. Well, we'll knoll them out into a nice curve, and then have them disappear either out the edge or into the felt. But we've definitely, I think, got enough wire to get us around whatever it is we want to be doing. There will be no problems there.
I'm not actually familiar with knoll in that context. Is sort of putting the wire in a aesthetically pleasing way. Is that?
Yeah, exactly. So, for example, we'd have them laid out like this, if we can get it top down. So I guess maybe looming them is a better way of putting it, but you wouldn't have them close together, just evenly spaced apart. And you use a little bit of fishing line to sew them down in strategic places to the felt. And then you can have them do nice coordinated turns, at right angles.
Right, you get that.
Sort of like that. That's the aesthetic I'm going for here. If we've got a show wire, then we might as well make the wire look nice.
You get that the surfer closet porn of the all the Ethernet cables that are all like synchronized.
Exactly. And one last thing we're going to need here, and that's I'm just going to take a measurement of the box because we're going to have the Raspberry Pi in there as well. My thought is that what I'd like to do is learn some Blender a bit more to learn how to do some 3D modeling, and to do that, the best thing to do is make a project. So why not build a Raspberry Pi case that'll look like a mini Naomi? Again, we can paint it the same color.
Oh, that would be fun.
Yeah. But we don't need to. I don't think we need to make it any larger than this case, for an example, and then we can, of course, enlarge it if we need to. But that's looking at about 9.5 centimeters.
A nice thing about Raspberry Pi is I'm sure there are all sorts of different case, designs you can download to sort of start with and have all the dimensions for all the ports perfectly and everything.
Yeah, and then that's the hard part of the way, and it's just a matter of adding a bit of extra substrate and then machining it off in the modeler before you bring it out. Right, so that was one side. The other side is
The idea of a little Naomi Raspberry Pi thing makes me it's like the Naomi needs one of those like the like preloaded little devices that like hooks directly up to your TV and has the it's got like 20 games on it. It's just like a set-top box.
Yep.
With all your favorites like typing Lupin typing game.
The typing of the dead. Lupin the typing. And Mavis Beacon teaches typing to Lupin.
Probably balloon fight too.
And balloon fight. I'm surprised they haven't given that a small revamp. Like sure, Splatoon's nice, but you could make a team-based shooter based around balloon fight, right?
Oh yeah.
I think that might be an interesting thing. Okay, so we've got some numbers here. That's this is the boring part of the project that no one wants to see, but you have to do anyway, because otherwise it never gets done. Or you start building before you measure and have no idea if it's going to fit, and then it doesn't, and then you're completely hooped. But let's head on over to the computer here and let's plug some of these numbers into Illustrator and just see what we'd be working with, how much of a size we'd kind of need, and if we could get something into a normal sized thing. So we've already got the 38. We need the 26.5. 0.3 centimeters. So let's adjust that. Selection. And that's going to be 23.6.
Oh, does Illustrator have like a built-in thing for little screw hole corner? Screw things in the corner, or is that just how it displays the?
No, that is actually, we were talking about features that we may or may not use in these things, and that thing is a method of changing the radius of your corners if you want to make squircles, which is kind of actually super handy.
That is kind of cool. That is a new feature.
Yeah.
I'm still on old Illustrator CS5 or CS6 or whatever.
I mean, you can get to that feature from the menus in the old versions.
Yeah, I mean, but yeah.
18 by 15. No, that seems wrong. 18 by 15. Thank you. Okay, so there's our power supply. There's our Naomi, and we can probably assume that the GD-ROM is going to be about the same size, but maybe a bit more square. So we'll add that just as just for fun. And 9.5 by 7 for the Raspberry Pi. Okay, so we're going to look at about 4 boxes in there total, if need be. Let's get that in there. That's right now we've got things sized for a 24 by 36 frame, which I think at this point is probably going to be too big.
It seems excessive, yeah.
Yeah.
About 24 by 24.
Ooh, 24 by 24 would absolutely work. But can I find a 24 by 24 sized frame in the wild? What's the next common size down for frames? Common frame sizes he put into DuckDuckGo, hoping to find something. Okay, so the next one down is 24 by 30. Let's see what that's like, because that seems pretty common. Document setup, edit artboards. 24 inches by 30 inches. Maybe let's go 30 inches by 24 inches. Hey there. So that seems a lot more doable.
Mm-hmm. I mean, it does still seem like a fair amount of empty space.
Yeah, and we're not going to want things to be right up against each other because that's going to make the wiring unnecessary.
That's a good point.
And we'll probably want, so if the Naomi is up like this, so we can read it, then that means that the input outputs are going to be on the left-hand side of the machine. So we'll probably want to have it in a corner here like that, and maybe the GD-ROM up here, or maybe down there, and then the power supply there.
Now, multiple things, like the power supply's got to plug into both the Naomi and the GD-ROM, or just the Naomi?
Just the Naomi. I mean, it's technically, it will have to plug into the power supply too, but I'm not actually planning to hook it up because it's kind of unnecessary for the system to run.
Oh.
But just having it there aesthetically would be kind of nice. I actually think I'm going to take this this frame size down one more pop, which could actually make things easier for me. 20 by 24. Let's see what that looks like. Ah. So let's go to artboards. 20 inches by 24 inches. Oop. Oops, let's go with 24 by 20. Keep doing the wrong thing. Okay, there we go. Now we're starting to get into a bit of a constraint here.
It still seems pretty pretty reasonable, though.
Yeah, I'm happier with this, I think, than I was with the big one. So if that's the case, we might be able to have it set up such that we can do the thing where the Naomi itself, or at least the when normally mounted, the GD-ROM drive kind of sits right here and overlaps with the top corner here of the Naomi. So the circle comes out and just kind of overlaps over these, not over the vents themselves, but just over the over the fins.
Oh, okay.
And I think that might actually look pretty good because then we can hide some of the input outputs of the.
Does that give it too much depth? Does that give it more depth though, or is the GD-ROM pretty flat?
The GD-ROM's pretty tall, but I don't believe it'll be any taller than the DIM board itself.
Even if you put it on top of
Yeah, because
okay.
it's only the. Here, let me pull up on NDI. Capture just everything. Just everything.
I see. ArcLight Dynamo linked to. Yeah, there you. Oh,
Yeah.
I see.
So here we go. So you can see up in the corner here on this one, you've got this lip underneath the
right. Okay.
drive spinny portion, which is really kind of a cool look. And then when it's mounted, it goes, over top of that edge there.
Right. I mean, I guess if you weren't using the if you were actually using the GD-ROM, it would probably not like being vertical.
Mm-hmm. Yeah, exactly. The other things too is that if we wanted to hook up the GD-ROM in addition to the power, which comes out here and connects to a split box. Again, the power on the Naomi is on this side here. I just realized the cursor that I'm seeing on my screen does not match up in the same location. You can see my cursor in the bottom left-hand corner here. On my screen, I'm waving that around the yellow label.
Interesting. And
Yeah.
if you do it fast so that it does the
get big. Oh
the
wow!
big
So you
mode.
actually get to see where it is too.
so the NDI software must be emulating the cursor for some reason,
Mm-hmm.
but in a way that is actually wrong.
Very interesting.
I wonder why. That's fascinating.
Yeah.
And
yeah.
that also means that when the cursor enlarges, there's actually there's actually
Something different being composited. Yeah.
Yeah, the compositing is slightly different. Interesting.
Fascinating. Anyway, so in addition to the power, we'd have to run that, but we'd also have to run this big old SCSI cable. That's right, it ran on standard SCSI. But so if we do that, that'll look. I think that'll make a nice look. Then it's just a matter of the power supply, which we can put kind of in the corner here, or if we want to make nice and easy, we put it over here.
Because the power input is on that side of the Naomi.
Yeah, and then we can actually, and it's, I believe, along the bottom edge too. So it's right around here where the power connectors go. So if we had the power supply out here, that would give it a nice method to chunk out. And I assume we're going to have that overlap a bit too, because it'll work. If we center that up, then yeah, having some the Raspberry Pi I intend to power just by its own by USB off of the Naomi's pins up here. So those will probably come out and then disappear under the. Oh yeah, you got to be able to see what I'm pointing at.
So the Naomi has like a 5-volt rail that would power the USB?
Yep, in fact, we've been doing that since the beginning. It's these 4 pins up here in the corner. Let's see if I can get it in. Yep, there we are. So yeah, the two outer pins of this connector here are 5 volt in and out.
Even though that's not actually a USB connector.
Exactly.
Cool.
And in fact, just to show it off, because
Wait,
hey,
there
why
is
not?
also a USB connector there too, isn't there? Isn't that in USB?
I'll get into that in a second. So that is just how we connect that to there. And we'll probably make some new cables with some new connectors to make that look nicer. But yeah, that just means whenever we put power to the Naomi, it immediately powers the Raspberry Pi as well. And then, reduces the number of power supplies we have to actually have when we're running this thing.
Right, that other connector is that's that cursed USB connector you have.
Yes,
right?
yes, that is the case of Sega doing the fun thing of, hey, let's use a USB connector, not for USB. We'll run our own thing through it, and based on serial.
They are way ahead of their time. USB-C does that all the time.
Yep. Well, it amuses me a lot because it kind of mirrors what we were doing with this project, trying to use HDMI connectors to connect a joystick to a JAMA harness. And that turned out to be a bad idea because of, as we found out, HDMI cable doesn't always have a one-to-one pin-to-wire connection, and that can be problematic when you need all those wires.
Oh, that some HDMI cables don't connect because certain pins are not used in the HDMI standard.
Exactly, and then certain cables don't always subscribe to all the standards. And also, depending on the standard, you could have a chip in your HDMI plug. Yep.
This is why we can't have nice things.
But yeah, so we'll have the wiring up there for the USB. We'll have to take the wiring off the harness there. That's for the USB codes and the burst connector. We'll bring that out for demonstration as well. This is something I'm really looking forward to breaking out and nulling. It's currently how it's set up is we've got this USB to RS485 adapter. This goes into the Raspberry Pi. This cursed end goes into the Naomi. But it breaks out into wires.
And there's special software on the Raspberry Pi that knows how to read that.
Exactly, how to translate any sort of joystick input into input for the Naomi through that USB JAMA cursed thing. But again, because we're splitting it out into wires, I thought it would be nice to hide as much of the just standard USB cablery as possible and just have only exposed colored or black and white wires just snaking across the top of that black felt. So there's that. There's another one that we can also hook up, which we aren't hooking up just yet, but we'll need to figure it out. Because that's the serial port that runs the emulator for the RFID cards that a Naomi runs. We'll also have to remember that we've got this, which plugs into the Maple bus and allows us to plug in our VMUs and Dreamcast controllers. I wonder if it would be worth plugging this directly into the Naomi and having it just sit there showing up inside the cabinet. I like the idea of that. Something about me also likes the idea of just running individual wires, again, from this thing hidden behind the bezel to the edge of the Naomi itself.
Because the hope is that, like, the idea is those ports would have to be coming out the side of the of the box so that people could connect to them, right?
Exactly. Again, hidden behind the bezel, but yeah, popping out. We'll have to have, it's worth kind of just drawing these out right now. So that's our power. Power. 72 point. No, all you. There we go. So our power up there. We got our quote USB. We're going to have that's our power. have our Dreamcast cables here, I believe. No, the Dreamcast is farther up. The Maple bus. No, not the dog, but
Is that a separate company within, or a separate like group within Sega that designed that bus? Is that why it's called that?
no, it's I'm not sure why it's named Maple, but it's it was the name for the bus that was used for inputs on both the Dreamcast and the Naomi itself. Where have I got the? I think I brought the bus in from home. This appears, yeah, this I think is the input bus from a Dreamcast.
Oh, cool.
Yeah. Fun stuff. Anyway, we're just trying to figure out where these cables go. So yeah, that goes underneath the USB. Power is in fact down at the bottom. So all the power comes out down here. And then that's the Maple. And that is the JVS, which is also right on top of the Maple. And then we're going to have our AV audio is going to be coming out here. Video is right next to it. And so those might be able to be just knocked right, a straight path right off to the edge of the frame. The other thing that we'll need to be worried about is up top here on the DIMM board. We're going to need to connect to the Ethernet, and I think that's another one where I'm going to try and take all the shielding off. And actually, that sounds like a bad idea.
I think shielding is like a reasonably good chunk of how Ethernet works.
Yeah. I mean, like we might be able to just expose the twisted pairs, but.
Still probably not a great idea.
Yeah, I think you're probably right on that.
We had a cable here actually that was it was a gigabit Ethernet cable, and it was quite long. It was like a 50-foot cable or something, and about 3 feet in from one side, for somehow. There was just a very neat window cut in the side, cut in the blue plastic.
Huh.
So and you could see the cable go through, and that cable ran at 100 base T, not gigabit.
I would bet. Okay, well maybe at the very least we can just use some flat Ethernet.
Flat Ethernets are cool.
Yeah.
I do like those.
I have way too much of that currently running under my baseboards at home. All right, so we won't need to expose the fiber connectors, thankfully. Even though, I didn't realize those just use Toslink as a connector. Maybe we could use the fiber to connect to a secondary Dreamcast.
Is that what that does?
Yes, yeah, they're for networking purposes.
Wow.
Because the NetDIMM is meant to connect to a server to receive just the games themselves, more than anything else.
So that was there would be four arcade cabinets beside each other, and
like your Mario Kart games.
Play a multiplayer game, right?
Yeah. Okay, so we got JVS, Maple. Those are your inputs. AV takes you out. Power comes out and goes in. Ethernet goes out and comes in. So all that's left is we need to run Ethernet to this thing as well. And JVS is going to have to connect there as well. As will another set of USB headers that will run to the edge of the frame, either behind one of the edges. And those will be the inputs for controllers. And then I guess power as well.
So you'll need like USB extensions on that,
Yeah.
I guess.
Or again, we could probably just run them directly as just wires and then connect them to actual connectors on the end.
Right. Yeah. Almost like the sort of what would normally be on the inside of a box or something.
And then I think what I want to do here too now is add, in addition, we're going to call this the dedication box. Plaque. This would be nice to just, do up a little plaque that looks brass, or maybe is brass, who knows, and just has the information about, the Naomi 2, its various specifications and dimensions, and maybe a little dedication on there or something. And I think that'll end up looking like a nice little framed video game system.
I like it.
Yeah, I'm now raring to get more at it now that I've kind of visualized it a bit. That's going to be great.
It's an interesting combination of like electronics and woodworking.
Yeah. The woodworking not going to be nearly as pretty as the electronics, but we'll do what we can. All right, I'll save that to desktop, and we're going to call that the first hour of Tinker Tailor Solder Fry. And what does that mean? Well, that means it's time for us to take a short break. We're going to get up, stretch our legs, swap our fluids, and we'll be back with some project potpourri in just a few minutes. Don't go all the way away. Welcome back to Tinker Tailor Solder Fry, where today we are continuing with our projects. Today we've dimensioned Naomi. We've done some preliminary layout on how we're going to turn it into a work of art that we can hang on our wall that is also functional. But now it's time to continue on with some other projects, because the Naomi's going to need a frame, and that means I need to go shopping, and thrift stores have a lot of frames. It could be a while, but we'll get to it. The next project, though, is this one. This is an interesting one. This is a Blackmagic 6K camera. We use these a lot. This one we've used a little bit less recently because thanks to the ravages of time, and no one's fault of their own, we have a little problem with that. And that problem exists right in here. That is our microphone port. Let's push that over a bit.
Yeah, this is one of our two main. These are the Blackmagic 6K cinema cameras, which are we have two of these, and these are sort of our main filming cameras. Yeah, and as you can see, it got a little enamored of the one of the pins for the XLR micro. I guess it's micro XLR.
I think so.
It's a weird standard that nobody else uses.
And so it is possible to get into this this piece, but not without disassembling the entirety of this camera. So we've tried a couple things already. We've tried hot glue, attempting to
it is, yeah. Unfortunately, it's the pin is actually like below the rim of the actual socket, so we can't just pull it out with pliers or something.
Yeah, we've tried pliers. We've tried the thinnest tweezers we have, and we can't quite get around the edges of it. So we're going to try something different today, and that is going to be solder. So the idea behind this is that we're going to take a very sharp soldering iron, and we're going to put a infinitesimally small piece of solder on the end of it, get it hot, place it so that it is touching that pin, and hold it in place until the solder cools. Then we pull carefully directly up. That's the plan. If this doesn't work, then our last case scenario is we send it off to someone to have probably have the whole port replaced. But this is our I feel good about our chances in making this work. So I'm going to start by, I was thinking about just putting in the clamp, and that seems like a bad idea. But what I want to do is set things up such that I can have a solid place where I can use these helping hands to hold the soldering iron in place while it cools. I think I'm going to use the bigger helping hands too for that, just because it's going to be a more stable surface. We may just use the sandbags too, but let's get those out and see. Or rather, let's start by extending the vise. Okay. And then let's move that around such that we're here. And we'll use the sandbags as a method of holding up that camera. Okay, that feels pretty stable to me. Just push things around a bit more. Okay, let's assemble the helping hands in a way that is helpful. And then we're going to choose our soldering iron. Let's get that up on top.
Would you say a pin is maybe like 0.5 millimeter?
I would say the pin itself is a full millimeter in width.
A full millimeter?
Yeah, it's not that small. It's not that big either, but it is definitely not infinitesimally small. Yeah, I'm going to need to just eyeball this, I think. I'm not going to be able to use the magnifier. And let's see about getting these in such a way that they can hold a soldering iron, or maybe I'll just see about doing it by hand. Let's choose our soldering iron, though. I'm thinking this round I might actually use the pine sol. And the reason behind that is that I think I have unless I don't have it here, the needle tip. Let's look around. There's something hiding underneath the foam in this one. Well, I've been wondering where some of this was. This is interesting. Crowbar is ready. Hammer is ready. Magnets are ready. And underneath that we've got... Hey, I've been wondering where this was. This is my at-home rack. Okay, and that's used for the regular... Hey! Remember we were looking for the tool for carving pumpkins? Found that too. What a good day. Do I have those anywhere else in here?
Yeah, that's a good point. We have like 1/4-20 mounts that we could screw to the bottom of the camera.
That's a good point, yeah, to make it a little more fully locked in position. Right, let me just clean this up here. You know what, let's save that for the end of the show. That goes home though as well. roll this up for.
I don't know if you want to do something like that.
Oh, just as a holder?
To use with the vise. Or
Yeah, let's give that a try. Thank you. That way it's a bit more locked in. That way we don't have sand everywhere too. Okay, let's make sure that's vertical. Make sure that the fabric is engaging with the teeth. Okay, that'll do. Now I just need to move that up there and dust all the sand off the table now. Okay, so the pine still isn't going to do it for us because it's not the right tip. That's okay. We'll work with the big old tip we got in our other guy, which will be an easier heating up experience anyway. Let's go, Hako. Okay. And we're heating up. Let's get our solder as well. So we're ready. All right, I'm going to start by cleaning off the tip.
is the idea to like solder a piece of wire or something to it?
The idea was just actually to use the soldering iron itself.
Oh, okay.
But yeah, no, I think a wire might just be getting too fiddly there. Okay. The wire might be the smarter idea, to be honest, because this is definitely a wedge tip. And that's going to... You know what? Let's give it a try anyway, because it shouldn't stick to the solder. Should only stick to the pin. It should not stick to the plastic.
It should certainly cool down a little faster, I guess.
Yeah. Let's give this a try. No, we're gonna need more solder than that. Okay. There we go. I also realized that a little bit of heat or even a little bit of melting on the plastic should be fine as long as it comes out.
Mm.
Nope, that was a little bit too premature, I think. Let's see if we can turn down the heat a bit too. Yeah, 400 should be enough to melt solder. It is indeed. Let's get a good amount there. Position it down. And now we wait. I guess some compressed air might not be a bad idea here too. But no, that's a bad idea. That's absolutely a bad idea. Compressed air would cause the just cause the solder to go everywhere. Okay. It's getting there. But I have a good feeling. I have a good feeling about this.
Is it? Yeah. I mean, you want to wait till the soldering iron's got to cool down to the point where the solder's all solidified again, right?
Mm-hmm. That does take some time.
But
I'm worried that my micro movements are just going to keep it from properly solidifying as well. But someone in the chat did have a good idea of just putting enough solder on there that we might be able to grab it just by the blob of solder itself. And I think that's not a bad try to have if this doesn't work directly. Yeah, that didn't get deep enough in there. So let's try that again. Let's just make a big old deep solder blob.
yeah, is there using the third hand or whatever? Can you actually like clamp the soldering iron in place? Or,
Kind of. No. Well, maybe that's a little hasty, but
or I mean, we have like other clamps around probably, but
yeah. Let's get the magnifying glass off there so that it's a little bit less fraught. The nice thing is this doesn't appear to be doing anything to the camera itself, to the plastic.
I guess they're designed to operate in relatively warm environments.
Mm-hmm.
And yeah, I wonder what kind of plastic it's made out of.
Yeah. I would have thought 400 degrees Celsius might be enough to go beyond, but all right, that's a big old drop of solder. Get in there, you fool. Maybe if I could poke it with the tweezers a bit. Get it right in there.
The solder should bond better to the metal pin than to the plastic is the idea, right?
That's the idea. Okay, that's a blob that's big enough I can grab with some pliers, so we're going to try that. It's not the biggest, but could be big enough. So we're going to let that be for a couple more minutes just to let it settle. Yeah. We let it settle.
Yeah, this is definitely, don't want to be overly hasty.
No. So in that sense, I'm just going to let that sit here for a bit, and we're going to get onto one of the other pieces of catch-up that I wanted to do that's solder related, which is this little thing here. This is a teensy that's attached to a adapter board for a Nintendo Nunchuck controller. The problem, I was going to be using this to play some Spin Rhythm XD on Rhythm Cafe using a Wiimote, or rather using a DJ Hero controller. But unfortunately, I have put on a 5.5 volt teensy, and the Nintendo Nunchuck runs at 3.3. So we need to get this nasty boy off and replaced with another one. And we're going to do that by hot air reworking with our good friend, the Apple iPhone lens ruiner, aka the hot air rework station.
But in this time, actually using it for what it was intended for.
Yes. All right, let's turn off our soldering iron. Doesn't need to be on right now. Love how wee the cable for this is. It does not give you much in terms of distance. But we should start by laying out some Kapton tape on our little friend here, so that my thought is it's going to be easier to remove this thing from the top than it is to remove the pins from the bottom, because the pins are pretty heavily soldered in there, where it's slightly less soldered on top. That's the hope.
I guess you want to be careful that you don't. Is there a danger of like desoldering the actual components on the teensy itself?
There is, and that's what the Kapton tape is for.
That's heat-resistant tape.
Exactly. Do I have my I have my cutting tools? Yes.
Kapton tape is 5 miles long. Doo-da, doo-da.
I mean, we're probably looking at mils rather than miles, but we'll accept it. Right, last time we used these was for modeling. Okay. So we're just going to lay that down on the inside of those solder points. And hopefully that'll be enough to... Oh, will one piece of tape do it for me? One piece of tape will do it for me. I'm a genius. Oh no, etc.
So the pins that are going through the two boards are not necessarily part of the. They're not actually part of the teensy. They're a separate.
Yeah, they're just a set of standard pins used for interfacing the teensy board with the adapter board.
And like a 3.3 volt teensy has the exact same pin out as a.
Exactly. The teensies I can get easily. The board, I think this was the last one they'd had printed, so slightly more difficult to get new boards. All right, I'm going to hold this with a thing.
Is there anything you need to Kapton on the actual adapter board?
Thankfully, no. I don't think there's anything on it. All the chips are underneath the teensy itself.
Oh, okay.
And the backside, there's just this button here. Surface mount button. But what I am going to do is configure this in such a way that I can lever things out of it. Because that's something we'll need to do. Where's a good levering tool? I know we have spudgers around here. Ah, there they are. Wow, after 10 years, this cabinet's starting to get full of useful stuff. All right, there's a good spudger. So we'll just use that to wedge things out once we've started to melt that solder in a way that's useful. And then just pop it off. Baron Von popping off. Let's take this sucker up to... You know, let's go all the way to 450. To hell with it.
Is this where you would use the solder wick stuff too, or is this separate?
Actually, you know, Paul, that's a very good point. That would make things a lot easier for me if I started with a wicking and then went to a. If we started with a wicking and then went to prying.
Takes a wicking, keeps on ticking.
Yeah, maybe it would. It's a long series of pops, so we might just want to pop this off if we can. We just need to get things nice and shiny first. Smell it started to heat up, so that's a good sign.
I guess if the solder's still on the pins from this, then you can just slot the new one down.
Potentially, yeah. Okay, so we're starting to get some bubbling here.
How heat resistant is the spudger?
Not very. Ooh, yeah, not very at all. Maybe we'll get some metal in there just to pry things up. Okay, I found those again. Where did... There you are. Okay, if that hangs off, that should be providing constant pressure. That's good. Here we go. Come on. There we go. Almost out. There we go. Oh no. Well, that is not what we wanted to happen, but...
Is that all the components attached to the captain?
Yep, sure is. Sure is a bunch of surface mount stuff attached to Captain tape.
Whoops. Oh, how about the actual thing? The adapter board is still okay, though, eh?
Yeah, the adapter board's fine. In fact, we can.
Theoretically, all those components are in the exact right spot attached to that relative to each other.
Yeah, it's this little resistor here that's or capacitor.
Oh no,
that's
so they did come off.
Really mocking me. Oh, and yeah, there's a few more pieces that have moved around. Well, you know what?
Right.
You learn some things every day, and today what I learned is that I didn't have enough enough space or enough tape rather on there. But like I said, the board itself just fine. And hey, I got a free micro USB connector.
I mean, free in the sense that it was a thing that you had previously bought.
You know what? I'm not going to be using the hot air rework for the rest of this. I think I'm just going
Hot
to...
air rework gets a timeout.
Yeah, it's all right. We're just going to clean these up a bit, just enough that we can get the new one on top. Because hot airing the new one on top might be a bit dangerous in its current state. Oh, yeah, lost a pad there too.
Man. That rework station, the hot air station, it's really a force for chaos. It just wants to heat things up. It doesn't care what.
Yep.
Doesn't care who it hurts along the way.
It's hot. All right, I think I can set this up now to get the 3.3 volter in there. So let's clean up a bit of stuff. Yeah, thankfully, teensies are relatively inexpensive, so I don't feel too bad about losing that one. That said, I'm going to keep all the parts just in case we do ever want to build ourselves an actual hot plate here on Tinker Tailor, and then we might be able to actually reflow those back in the future.
So, in hindsight, taking this as a learning opportunity would have been to try to heat up the bottom instead of the top,
Maybe that might have been a better idea, but
or
still hard to say.
yeah, it's such a tight confines.
So what I'm now doing here is just heating up the pins themselves to attempt to kind of lever this on. I don't know if this is a good idea or not.
It's a lot more focused application of heat.
Mm-hmm. Straighten it out a bit here.
Do you have the whatever cables that you need right here to know whether this connection has successfully made it?
Sadly, I do not, actually. I really should have... I had it in my head to put them in the trunk, but did not do so. That said, I think this is actually well connected.
Nice thing is they're fairly like straight ahead pins.
Yeah, I can see them all here. You know what I'm going to do is I'm just going to tap them in from the top here. Let's give it a little bit of flex just to make sure things go where they're supposed to. Oh my. Okay, that flex jar I think is done, folks. The brush portion appears to have cracked almost completely. Time to get a new makeup. Time to get a new makeup jar.
Oh, the flux inside is fine, but the brush is all messed up.
Yeah, well, it's really just the cap. But I might just leave this here rather than have it transport and spill over on the way home, though.
Somebody mentioned that for the camera that a little bit of flux might help the
The adhesion
solder.
too? Yeah.
Just the solder attached to the pins, but on the other hand, it could also cause things to, flow down deeper into the camera, which would be not so
Yep.
good.
Yeah, what we don't want is the pin mating itself with the pin receivers, the socket.
Right, that's true too. If solder goes like around the pin, then it actually is going to be just welding itself into the socket.
Yep. But it looks like we're getting some good connections here.
Someone suggested bringing it to a dentist. They've got little teeny weeny drills.
They do have drills.
Probably not designed for metal though. Although, I guess depending on what your fillings are made out of these days.
I mean, we're always told that tooth enamel is one of the hardest, it's the hardest substance in our body, that's for sure. But it's, a pretty hard substance. The hygienists still get in there with their steel scrapers and just go to town. That always amazes me too, that they can just get in there and just scrape away and, yep, your teeth are fine. No problems.
I mean, it's not what I would call pleasant.
No, it's, by God, it's not pleasant, but it's kind of cool to know that we have that kind of armor in our bodies.
Wolverine sits down in the dentist chair. Your teeth enamel is the strongest stuff in your body. Oh, yeah?
Yeah, bub. Okay, that is hopefully one project down. We'll never need to look at that because that'll hide inside some things. And this, oh man, I am going to keep that in a little baggie as well because that's too much fun for us not to remember. That time that a teensy tore itself apart like a Rumpelstiltskin. Got so hot and angry.
Wait, what? Is that part of the Rumpelstiltskin myth?
Oh yeah, no, that's the end of the stories. He gets so mad that people guessed his name that he stomps one foot into the ground, like to brace himself, and then tears himself in half.
Oh, the version I read did not have that bit.
Yeah, you ever get that mad that you just tear yourself in two? All right, I think we're ready to try pulling, extracting, and hoping.
The tiniest Excalibur.
Now, should I twist it first? No, I should probably just go straight up if I can.
I think so, yeah.
Okay. Grip. Oh.
Nothing?
No. So.
Does it look like it made contact with the pin?
I would say that. Let me have a look at the under the magnifying glass here. It got close, but it didn't go all the way. Well, we got one more thing we can try here, and that's we've got some pins, I've just realized. Do we want to try gluing or soldering a pin to that device?
I mean, that does allow us to sort of ensure that it is directly in contact with the other pin, because we can actually, if the pin you're attaching is the same or smaller, then you can actually put it against the other pin
Yeah,
and
I can
solder
also-
them together.
I can also load the pin with a bit of solder beforehand, and then also load it with some flux too, so that it'll hopefully get through. So yeah, let's touch the pin with some flux. So ideally, the edges of that connector aren't going to suck any flux down, and even if it does, it won't get all the way. Okay, and then let's get this pin loaded.
We're gonna finally end up taking this to the repair place with like half the body is completely melted away, and they're like, "What happened?
Well,
a pin got stuck."
if you're curious, we have a stream for it. The other nice thing is by doing it this way, I might even be able to just let it go and let it dry.
A series of circumstances.
I'm gonna keep this clean if I can. Ah, the pin is in the tweezer. Okay. Hmm. There we go. That's the kind of thing we want to do. Is kind of make a jig for it. And then we're going to load it up with solder again.
Jig, the word for keeping some building a thing to keep something still, or an extremely active dance.
All right, here we go. Last try. Come on. Okay, let's leave that for a few minutes. But if this doesn't stick, I'm out of ideas, unfortunately.
All right. Well, we definitely gave it a shot.
Yep. No one can say we didn't try a lot.
Well, they could, but they would be liars.
The trouble is it's incredibly difficult to tell if it's actually in there or not. Because I don't want to touch it until it's solid, but I also don't want to... I don't know if it's connected. I'll just use this moment to remove some solder from some of the tools we've been using today. What else did I bring that was necessary? Nothing. We are out of projects. Oh, no, wait. There's still one more, but who knows if we've got time to get into it. Yeah, we do. Let's just leave this, because it's a quick question. The Okie boys have been having trouble with one of their sticks. Ian's going to see if he can figure out what's going on here. So the first step is to get the top off this case. And that's a job for Allen keys. It's video game related, so it's probably metric. Okay. So what we'll do here is we'll pop into it, do a quick test, and a quick continuity test on the stick, find out which direction it's sticking, see if we can clean it, and if not, we'll just do a replacement in future. The stick has a button release to open the top. Does it? This one does not. This one is fully sealed. Yep. I think it's easiest to get in here from the top. Yeah, screws all around and just a solid piece on the front here. That said, easy to unscrew. Oh, Street Fighter 4. I honestly have nothing to say about you. Two more. You can tell that this has been well used and well loved by how oxidized the screws are on top. That's hand grease. Hand grease is love.
Mm.
There we go. Easy peasy. Oh, that's a nice block there for the connectors.
Very nice.
Yeah, looking at all the finger goo in there. All right, let's just disconnect the stick. Break the glue. Break the glue. Okay, yeah, this is going to be an incredibly... Ugh. He's not paying me to clean the controller, so we're not going to do that. But he says it sticks.
When you say sticks, are we talking like mechanically sticks, or the like the or just the input stays too long?
That's my assumption, is that the input is sticking. Impressive that this thing has Sanwa buttons in it already. Okay, there's a second screw. And there's a third screw. I was saying to Adam that I'd be happy to replace the the switch on it if the switch is the problem itself, but I might not be able to actually do that completely. Oh, yeah, the stick needs to come off too. I gotta thank Dandy Geek in the chat too for getting me into more arcade maintenance-y stuff, because I am no longer afraid to get into some of this stuff, nor am I worried I'm doing anything wrong. I feel like I've become skilled rather than just a dilettante. Okay, there we go.
I mean, stuff still breaks,
Oh,
but
yeah.
now you're not worried about it.
Exactly. See, look at that. Now I can take a stick out and not feel like I'm going to completely hose it.
And now I remember talking when you were doing those other fight sticks. There's the talk like the restrictor plate that denotes whether it's like a 4-way or an 8-way or.
And that's this one is definitely, it looks like a 4-way, if I'm reading this correctly. Let's see if we can get that off too. I don't think I need to get that off actually to do a test. I don't need to get any of this off to do the testing, but it certainly helps me have a look at the state of the switches themselves. Restrictor plate off, and there we go. There's our 4 switches. In fact, there's our switch plate, which we can now, we could absolutely swap one of these if we needed to, but.
So looking for any wear on the idea is that like maybe one of those buttons is sticking in when it gets
That's my
pushed.
idea. So what I'm going to do is I'm going to hook that up to my multimeter here on the continuity test, and just check each of the switches, give them a quick click, 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 see how that goes. And if everything seems hunky-dory there, then maybe we'll just blow into them, I guess. Hook up the alligator clips.
Think about like in a heated game of Street Fighter or any fighting game, you're going back and not only are you hitting all the buttons really fast and going back and forth on the joystick, but you also because of the the height of the joystick and stuff, you sort of also have quite a bit of mechanical advantage against the switches that are down below. That I can imagine could put quite the wear and tear on these things.
That one sounds good. Seems good there. Nothing there. Interesting. Well,
Those seem all fine.
they do. It's going to give them a quick blow, too. Just make sure again that haven't ruined anything. Good.
Yeah. There is, of course, yes, always the electronics equivalent of turning it off and turning it back on again, which is taking it apart and putting it back together.
Yeah.
They are snapping back appropriately and everything.
Yep, the sound goes off when I release it, so that to me feels like it's working as intended, at least on the switch portion itself. So I guess we reassemble and hope to hell I reassemble it in the right direction too. Right, need the spring first. Where are you, spring? There you are.
I think keep jumping backwards now.
Get that a little clean with my fingers. Okay. Reinstall restrictors. I mean, honestly, if it is bad, I can always. Technically, I could probably replace the directional stick with one of the sticks we've got from the Oki tournament sticks. Okay, go through the hole. Cap it off. Where's that ring? Snap rings. My second nemesis. There we go. All right. Nope, that needs to go that way. And hopefully that's all I'll need to do with regards to hooking the stick up in the right direction. Oh, good. I was thinking to myself, I don't have a laptop to test this. What happens if I do hook it up upside down? I guess Nelson will have to learn how to play Goofy Foot. Yeah, that's right. I remember Skate or Die, 1986, I want to say.
Yeah, don't you like playing with inverted controls?
I do. As I still need to make the T-shirt for. Yes, I fly right. WRIGHT. Pull back to go up. Okay. There we go. They needed a little bit of room to maneuver, but now we're back right where we need to be. Clink, clink. Button up. Button up. And buttoned up. All right, let's flip it over. Plug in the stick portion. Glue side to glue side, of course. And hopefully that is the orientation I'll need to be in. Ooh. Okay. Nice steel plate on the top of it here over the lips. All right. Gotta use the other laptop. Where did it go? Ah, there it is. macOS still does not have a good system for reading joystick inputs from USB, so. Gotta go with the utility OS. Windows 7. 10. Windows 10.
I mean, there's web apps that can do it now. But
That's a good point, yeah.
I don't know if Safari or Chrome for Mac supports that API. But
Honestly, at this point, I just want to see if it or see if it's working for the first time, rather than have to troubleshoot whether or not the system for reading inputs is working.
it's probably a good idea.
Right. Scan my finger. Joystick. There we go. Set up USB controller. Arcade stick. Street Fighter 4. Okay. Up. Oh, interesting. Yeah, this stick is having a time. So in DP mode, or in LS mode, nothing's coming through. DP mode, we get left, right, up, down. So you get all 4 ways there. Nothing there.
What's LS mode?
I'm honestly not sure. I think it's left stick and a right stick are the modes. It has always been my interpretation. I honestly don't know.
So is it not working?
It's partially working, and that's the annoying thing. Come on, connect to our Wi-Fi. No one quickly. Okay, LS mode flips the controllers over to left. It's left stick mode, but that's default, right?
DP is D-pad.
Ah, here we go. This is someone on Reddit was smart enough. DP is directional pad, LS left stick, RS right stick.
Oh, makes sense.
Okay, so we keep it in DP and that should be fine.
For the purposes, for console purposes, for the purposes that they're using it, is that what mode they use it in?
I'd assume so, because yeah, if I go into either of the other modes, Windows doesn't report it at all. So I'm going to assume that that's a one of those Xbox things, because this is technically an Xbox stick first.
So is it, and when it is in that DP mode, are you noticing any sticking or anything? Or
Not at all. It's now, I also didn't test it out beforehand to see what it was like before, but
Right, I guess that would have been useful.
I'm going to call this good. I'm going to button this up and say that we have
And the up and down appear to be correct.
up and down absolutely are correct too. we have not swapped one problem for another. But yeah, that's good. So let's button this all the way up, and then we can find out whether or not we can pin, or we can take a pin out of it, or if we've got to put a pin in it for next time, or rather, next shipping window to Blackmagic. But yeah, I would say this is a pretty dang repairable fight stick. I am impressed. It's not as easy as the ones that have the button to open up the whole thing, like the fight sticks that are paired to the Naomi are. But if you know what you're doing, that's not really a hard barred entry. one slot says maybe check the diagonals. Remember them noticing issues with crouch blocking. I would. I don't think I need to do that because the diagonals are not a multi-report or a single direction. They're just a combination of left and down and up and right, etc. Because there's only the 4 switches.
I mean, doesn't the restrictor mean it can't go diagonally?
Ah, yes. It's sorry. This is the restrictor that's the one that allows it to go diagonally, but does not give you a left, right, up, down restriction. You've just got the corners that it pushes to,
Right.
rather than 8-way. There you go. Quad gate does not mean it only detects 4 cardinals, just that there are notches in those directions. Yep.
Right.
There we go. Thank you. All right. I'll put that back in the friend zone for their use. I guess you'll find out tomorrow, assuming that that Nelson is on tomorrow's stream. All right, this is the moment of truth. This is our last bit for the day. Yeah, it didn't connect.
Not at all.
Not at all. So. Yeah. Oh, well. It was worth a try.
It was certainly worth a try. Yeah. I mean, the nice thing is that for the uses that we use these cameras for, we are actually fairly seldom needing both of them with audio inputs.
At the same time. But,
Yeah, because usually we'll only be recording audio on one side, in one of them. But that is annoying.
Yeah, it's annoying and unfortunate. Because it's not as fun to end an episode on a non-success, but sometimes that's where we have to go. So I want to say thank you. Oh, Flying Raccoon says, question, are chairs planned for soon still, or is that on James's scheduling? That's absolutely James's scheduling. I've gone back and looked at, James wants me to work on his human scale chair to modify it to keep the arms all the way up. And we'll need to...
to like lock the arms up?
Yeah, and I've gone back through my previous episode where I did the arm repair to see what sort of stuff we'd need to do, what's going on inside, and my initial thought was actually for us to just use a torch-based soldering system, like for pipes, and attach the ratchets to each other, but the ratchets are smaller than I remember them being, so that may not be the system we want to use. It's something that's going to require a little bit more research before we get them on screen, and of course, James's schedule as well. But for the moment, we want to thank all of you for watching Tinker Tailor Solder Fry this week. It's been an absolute pleasure having you here, whether you're in the chat, chatting along with us, at home watching silently, or if you're one of those people who's a subscriber here at twitch.tv. We also want to make sure to thank those of you at patreon.com/loadingreadyrun for your continued support, monthly, daily, and yearly, as the rap people would say. Helps us keep the lights on, helps us keep doing what we're doing, and we really appreciate that you do it for us. So once again, thank you so much for watching. We will see you in a fortnight. Only that one time in Fortnite, ever forward, learning out of spite. Good night.